Good morning, 8LA and 8LB. This is a quick video today about trigonometry. Again, we're going to focus on how to find the angle, the missing angle, or maybe how to find a missing side. So this is exclusively trigonometry, and towards the end of the video, we're going to go over two challenges that you may encounter throughout the exercises. So for now, here's what I really want you guys to do. Take a piece of paper, take a pen, and grab a calculator because you do need it. That being said, I have been looking at the submission rates on the recent assignments, and it's not up to par. If you are not submitting your work, you will not be able to make up for it later on. The only way you could explain that to me is by email. If you explain to me that, oh, there's a family emergency or whatever it may be, sure, please communicate with me. Otherwise, I will assume that you have not done the work, in which case it will go in your gradebook. So please submit all your work through Edmodo. There is a tab for posting assignments. And if you have difficulties with it, ask a classmate or send me an email, and I'll make sure I'll address all the issues. But you need to do your work. Otherwise, we'll be a little bit behind in terms of curriculum. At this point, talking about curriculum, guys, you will be fine in the sense that we are on track with the curriculum. There will be 4 chapters after we're done with this one, and it should be fairly doable. So I'm not really too worried about timing the lessons, as we have covered a lot of ground lately. So, trigonometry, right triangles, how do we use it, and what can we do with it? You can find missing sides, and you can find missing angles with it. That's the big idea at this point in your rate. So I gave you 2 examples. One is a right triangle where we have to find a missing angle, and the other one would be a right triangle where we would have to find the missing side. So we're going to try to go through with it following that 4-step process. So first thing that's very important to identify is that we actually are talking about right triangles. So in this case, we're going to try to solve question number 1. What is angle A? So, first step, you circle the angle of choice, the angle of interest, which is this one. Step 2, label your sides. My longer side will be the hypotenuse. The side opposite to my angle will be my opposite side, and the side touching my angle will be the adjacent side. Now we're done with step number 2. Step number 3 is all about picking the correct trig ratio. So we have sine, cosine, tangent. Which one are we going to use this time? Well, we are trying to find the angle. So we must know 2 sides. If we already know 2 sides, we should be able to find the angles. And the sides that are given to us in reference to this angle are the opposite and the adjacent side. So the question is, which trig function includes both the opposite side and the adjacent side? And that is my tangent function. So my tangent of question mark would be equal to the opposite side, which is 6, over my adjacent side, which will be 7. So that's what we have. I made sure I wrote out the opposite side and the adjacent side, just so you can have a sense of tangent of an angle is equal to the opposite over the adjacent. Remember, that kind of knowledge, you need to remember it by heart, because this is what's going to help you pick the correct trig function. If you pick the wrong one, the calculator will not know. So you need to figure out what are the sides given and which trig ratio to use. Now that we have this, let's try to write a little nicer. So we have tangent of my angle is equal to 6 over 7. So now I'm going to use the trick that I taught you guys last time. If I want to move this on this side while keeping the angle isolated, we have to use the inverse function. So we're going to do just that. Question mark is equal to the inverse function of tangent of 6 over 7. And now all I have to do is use my calculator. So I'm going to grab it. We have it, and we try to locate where is my inverse tangent. It is usually the same button as tangent, but you have to use the button shift, depending on the calculator. So I'm going to do just that. Tangent inverse tangent of 6 divided by 7, and I get an angle of 40.6. 40.6 degrees. And the next question is, does that make sense? I mean, let's try to think of it in a different way. Imagine these two sides were equal. If these two sides were equal, well, this angle and this angle would be 45. As this one becomes a little bit bigger than this side, as AB increases by a little bit because it's not exactly 6, it's 7, it gets a little bit bigger, what happens to my angle? Well, angle A will decrease a little bit from 45, while the other one will increase a little bit. You can try it for fun, see what happens when you go from isosceles triangle, right triangle, to a triangle where one side becomes slightly bigger than the other. You will find that the angle actually decreases a little bit. So this answer kind of makes sense, so I'm going to box it, and we are good to go. Now, while this sounds extremely complex and looks complex, when I apply it, it's really a one-step process. And that's really the idea here. What we want to do is apply the process as many times as possible until we get comfortable with it, and then we just use a calculator. There's not that much thinking involved at this particular point. Now, let's look at the second question. The second question gives us this right triangle. We know one side, we know one angle, and we're looking for the hypotenuse. So, this is what we're going to have to work with. The sides are given to us. So, first, four-step process. Circle your angle of reference. Well, this one is my angle of reference because this is the angle that I already know. So I'm going to pick this one as my angle of reference. Step 2. Label your sides. Well, this will be my hypotenuse. The longest side is always the hypotenuse. The side that is opposite to my angle will be called the opposite side. And the side that is touching my angle will be called the adjacent side. So now we have done step 2. Now that we have all the sides labeled, let's try to pick the trig ratio. Trig ratio is step number 3. Pick your angle, label sides, pick trig ratio, do math. So right now we're at point number 3. So I am given my adjacent side, and I am looking for the hypotenuse. So let's try to think it through. Hypotenuse, adjacent side. Which trig ratio? Cosine, very good. That was cosine. So what are we going to have to do? We're going to have to do cosine of 55 degrees will be equal to my adjacent over hypotenuse. 7 over question mark. Now keep in mind the 7 is my adjacent and the question mark is actually the hypotenuse. Again, very important to label the sides correctly and to know the trig ratios correctly as well. If you don't know them and you pick them at random, try to calculate the probability of you being right. You will find it's pretty low. Make sure you know this, this theory. You have to know the trig functions. So once we have this, well, same as usual, we try to isolate the value we're looking for, which in case is the question mark. A little bit of math, and we eventually get that the question mark is equal to 7 over cosine 55. Very good. So now that we have this, we got to use a calculator. And again, I'm going to get the answer in a second, but that whole process was extremely quick. The more comfortable we get with these, the easier it will get to solve the higher level questions. So now that we have this, let's try to calculate this thing. 7 divided by cosine 55, and you get a value of 12.2. 12.2. All right, now the question is, does 12.2 make sense? Well, the first thing I want to ask you is, should this side be bigger than the adjacent side? I would say yes, it has to be. So that would make sense in regards to that. In regards of the drawing, I would also believe that this would be semi-accurate. So according to my drawing, my thinking, and the calculator, I think my work was actually accurate. So that should be enough for this. Now, we know how to find sides, and we know how to find angles. But there is a couple other questions that you may get from trigonometry. For example, what if they ask you to find something like the area of a triangle? So stick with me for a second, and I'm going to give you a brand new problem. This problem will be considered intermediate / challenging or advanced. So let's say we have a triangle, all right, like this. It will not be drawn to scale, and we have a height, the height of my triangle. This side right here will be, let's say, 7. So this side is equal to 7. This side right here will be equal to, let's say, 12. All right? And we got an angle right here of 53 degrees. All right? So I'm going to repeat all this for you. I have a right triangle, I have a regular triangle, and I drew the height right there. The distance from the height to one of the point is 7. This particular angle is 53, and we know that the hypotenuse of the other right triangle is 12. My question is, can we find the area of this triangle? So this is what we're going to try to do. The first question we ask yourself is, how do I calculate the area of a triangle? Well, this is really what we have to work with, by the way. Even though we talk about trigonometry and all these fancy terms, at the end of the day, the question is area. What is the area of a triangle? Well, that is not too difficult. The area of a triangle is always equal to the base times the height over 2. And that we know from pretty much primary. That being said, we are not given that information yet. We are not given the base, because the base would be from this point to this point, and we don't know that yet. And we are missing the height as well. The height is not given to us. If we had it, yes, of course, that would work. But if we don't have it, then we probably need to find it. So, the first question is, what do we look for first, the base or the height? So I'm going to go ahead and try to find a right triangle. And I notice, oh, there is this very cute right triangle right here. And 2 information is actually given to me. One is the angle and the other one is the side. That should be enough to figure out what the other sides are equal to. Now, we could figure out what this side is equal to. Yes, we could, because we know trigonometry. And we could find what this side is equal to as well. But do we need both sides? Because we could figure out everything. But do we actually need to know both of these sides or just one of them? So try to think about it. You can pause. You can try it out. And the answer is no. We don't need both sides. All we need to know is this side right here, which will be my height. This is what we need. So, step 1, we're going to try to figure out the height. So, we circle the angle first of all. And then we're going to label all of our sides. The 7 right here will be my adjacent side. And this guy right here is opposite to my angle. That would actually be the opposite side. So now we have it. We're trying to find the opposite side, but we are given the adjacent and we know the angle. So, adjacent, opposite, tangent. So we're going to write tangent 53 is equal to the opposite over adjacent. So it's equal to the height, which we don't know yet, over 7. That's what it means. So what is the height equal to? That's when we have to do step 4, which is a little bit of mathematics. And you eventually find out that the height is actually equal to 7 times tangent 53. So we're going to try to work this out real quick and see what the height is actually equal to. So 7 times tangent 53, and we get the beautiful value of 9.3. Great. So now we actually know the height. Yes! This is half the battle. All right, 9.3. So now we know that this is equal to 9.3. The big question is, what is the base? Well, the base in this case is the combination of this side and this side. That together is representing the base of my triangle where the height is 9.3. So we're going to have to figure out this second line segment. And we're in a quite easy situation here. And the reason being is that we have enough knowledge to figure out the third side. Now, you may think, what shall we use now? Should we use trigonometry or should we use Pythagoras? Now, obviously, trigonometry could work, but technically speaking, in this particular case, well, we have a right triangle and two sides are given to us, so maybe we can use Pythagoras instead. I think it'll be a bit faster. So we're going to pick this length right here to be x, and we can simply write 9.3 square plus x square is equal to 12 square. All right? Now that we have this, we should be able to isolate x squared. So let's try to check what x squared is equal to. Well, that will be equal to 12 squared minus 9.3 squared. Now, obviously, we don't want to do squares with decimals, so we're going to use a calculator for this. And you're going to get, give me a second, 57.51. X squared is equal to 57.51. Whoa, that is a very big value. How is this possible that we have 57 and 7 here? Well, the reason being is that x is not equal to 57. It's x squared. So if we have to find out what this value is equal to, we're going to have to square root the 57.51. So let's try this. We're going to square root 57.51, and you're going to get a value that will be equivalent to 7.6. So this value right here is 7.6. Whoa, nice! We have the height and we almost have the base. The base in this case would be equal to 7 plus 7.6, which will equal to 14.6. And now we have it, guys. There was a very long question. We had to use two different concepts, but we're almost at the answer. So let's try to solve this. We got 14.6, the base, times 9.3, the height, divided by 2, and you get the value of 67.89 unit square. Now you may ask, why are we using unit square, sir? Well, the reality of it is that we didn't really use any units yet. We don't know if it's meters, centimeters, or anything like this. So instead of writing a specific unit, we're going to keep the unit as the word unit, which will represent any unit that we want. So make sure that when you use areas, you have to pick the unit square as the unit of measurement. So that's pretty much it for this. Now, if you want to stick with me a little bit longer, I'm going to ask you a different question, a more challenging question this time. The mountain question, and I will actually go over how to start the problem, and hopefully you can finish it before we meet back on next Monday. So let's try to erase all this, and let's start with a new question. So imagine you are trying to measure, let's say, a mountain or a very tall building, but you cannot quite get to the base. So let me show you in a drawing what I mean. It will clarify things. So, let's say we pick Mr. Niels. Mr. Niels is right there. Alright? And he's at a certain distance that I don't know yet from the base of a huge mountain. Alright? So this distance, I don't know what this is. So this distance, we're going to call it D for the time being. Since this is representing the height of the mountain, this will be also a right angle. And the last thing is, we really want to get some angles in there. So Mr. Niels is going to look at the top of the mountain, and what he finds is an angle of elevation of 30 degrees. Meaning that if he's looking up at the top of the mountain, his eye is going to make an angle of 30 degrees with the ground. That's interesting because we don't know any distances yet. However, we know one angle, and this big thing right here, well, it is a right triangle. So maybe there's something we can figure out. Anyway, he's looking up 30 degrees. Next thing he tries to do, he decides to take 100 steps. So let's say he walks 100 meters. So now he's right here. He just walked a distance of 100 meters. Very good. So he has walked 100 meters, and now again, he's going to look at the top of the mountain. So when he is looking at top of the mountain, what we find is that now the angle is 40 degrees. So now we're going to have to think about first, what is the question? And the question is, what is the height? So let's try to put it in red. Find the height of the triangle. Okay, and now this is a little bit difficult. I'm going to put the calculator away because you're going to have to do some thinking. The calculator will not always help you. So right now what I see is I see two right triangles. I see the big one right here with an angle of 30. Alright, that's one of them that I see. And I see another right triangle with the angle of 40 degrees, but I have no measurements. Alright, so let's try to figure out what the values that we don't know. Let's try to name them. So first, the distance between Niels the second time and the height of the mountain, we'll be calling it x. So that would be my x value. I don't know what it is. Second thing we're going to try to figure out is what is the height, what is the variable for the height of the mountain, and we're going to call it h. Alright? And even though there's not much that we know yet about this right triangle, I believe that we can write a couple equations. First, let's look at the bigger, larger right triangle. So this angle is 30 degrees, and this distance right here will be 100 plus x. Why 100 plus x? Because we are looking at the larger triangle. Alright, and the sides are h for the height. The base right here will be 100 plus x. And finally, the angle of 30 degrees will still be here. Using this, I believe that we can write some equation already. I have my angle right here. This is the opposite side, and this is the adjacent side. So we're going to have tangent of 30 degrees is equal to h over 100 plus x. Ooh, that's good. The only problem is, well, there is two values that we don't know yet. H and x, we don't know what it is. It could pretty much be anything at this point. And one equation with two variables is not going to tell us what is the value of the variable. So we have to look at the second triangle. So now let's look at the second triangle. The second triangle looks a little bit like this. You have an angle of 40 degrees. This distance is x, and the height is the same. Now, if you take a look at this triangle right here, you notice that yes, the measurements are transposed to this particular shape. So using this, this is the angle of 40, opposite side, adjacent side, tangent 40 is equal to h over x. Fascinating. So what could we say about this whole thing? Well, I don't want to go too far with this because I do want you to think a little bit about it, but let's write out the simultaneous equation that we have right now. Tangent 30 equals to h over 100 plus x, and then tangent 40 is equal to h over x. Now, this is what you have to find. You may say, oh, teacher, I don't know how to do it. This tangent 30 is confusing me. Well, what you could do, worst case scenario, is think of tangent 30 as a set value, because tangent 30 is a set value. So try to transform these two values, if you want, as decimals, round them, and then figure out how to figure out what h and x is equal to, and then you have solved the problem. I know this is a bit of a long process. This is really the extent of what we're going to learn in year 8. If you're able to solve this, you pretty much have a strong command of trigonometry. If you have any questions, please send them to me, talk to each other, submit your assignments, and make sure that we are ready to start reviewing chapter 9, 8, 7 when we come back. All right? Guys, take care, be safe, send me any message if you have any questions of anything. Cool? Take care.